Okay, here we go. Stand by. 3, 2, 1.
The thinking atheist. It's not a person. It's a symbol. An idea.
The population of atheists in this country is going through the roof.
Rejecting faith. Pursuing knowledge. Challenging the sacred.
If I tell the truth, it's because I tell the truth. Not because I put my hand on a book and made a wish.
And working together for a more rational world.
Take the risk of thinking for yourself. Much more happiness, truth, beauty, and wisdom will come to you that way.
Assume nothing. Question everything. And start thinking. This is the Thinking Atheist Podcast. Hosted by Seth Andrews.
Today's broadcast is about science. Specifically, we're getting into the hard science of evolution. I'll bet you're a lot like I am. You're not just into science, but you're also into science fiction or sci-fi. You have got to check out this series. It's taught by physicist Dr. Charles Adler at the Great Courses Plus. It's called How Science Shapes Science Fiction. And he covers everything from Kubrick's masterpiece 2001 to Mark Watney's character in The Martian. He gets into Avatar and Doctor Who and so much more. It's the science with the fiction. What works, what doesn't work. Man, this is a fun one. And it's also a serious science education. The Great Courses Plus has thousands of lectures on topics ranging from science to history to the arts to learning an instrument to how to train your dog. I mean, there's something for everybody streaming right into your life, including on the Great Courses Plus app, 24/7, anytime, anywhere. Start your journey today with the Great Courses Plus. Your future self will thank you. You can use my special URL to sign up, thegreatcoursesplus.com/Seth. When you go there, you get a 14-day trial with unlimited access for free. So go now and sign up, thegreatcoursesplus.com/Seth. I mean this in the best possible sense of the word. But whenever I've had the opportunity to have a conversation with the guy who is my special guest today, I always come away feeling stupid. This is probably one of the smartest, if not the smartest guy I know. I mean, I just come away and I'm like, I'm an idiot. Because I walk into a room and think, why did I walk in this room? You know, someone tells me a piece of information, I can't recall it, or I have to sort of squint as I'm digesting it and trying to process it, right? I'm navigating like the every person. Dr. Donald Prothero has this encyclopedic knowledge of geology, paleontology, loves to talk about everything from the cell to the cosmos to dinosaurs and so much more. I'd like to come back to the subject of evolution every once in a while on the show because we're still having those conversations out there. Well, evolution, fact or fiction? Evolution just a theory? How does evolution even work? I didn't come from a monkey, blah, 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 blah. Let's get into evolution and let's talk to my special guest, a prolific author and science educator. If you get a chance, go on YouTube and watch the video of his lecture called Evolution, What the Fossils Say and Why It Matters. He gives lots of examples. And now he's got a new book out that takes the conversation even further. It's called The Story of Evolution and 25 Discoveries, the Evidence, and the People Who Found It. Well, this was too good an opportunity to pass up. Dr. Prothero, it's good to have you back on the show, my friend.
Thank you for inviting me. Always enjoy talking to you.
I want to start out outside the book talking about a lot of these discoveries. You know, I was just sort of browsing these fossil discoveries. I know there was one in September, China discovery about a burrowing dinosaur. I can't even pronounce the name. Changmiana something. So we don't have to talk about that specifically, but certainly you as a dinosaur and a fossil guy have to be following a bunch of these discoveries, right? Are you keeping up?
I try the best I can, but there's like 2 or 3 a week typically, and I actually have a real day job too. So I don't have a chance to go and actually track them all down. I mean, my feed of scientific articles is pretty steady, so I keep an eye on them and glance at their titles. And then if I'm really interested, then I'll sit down and read it. But, I'm teaching 300 students in 4 classes this semester, so my plate's pretty full.
So let's talk about 25 discoveries. You just boil it down to 25, or did you handpick 25 of hundreds of discoveries?
Yeah, it was sort of a combination of things. Several years ago, I was trying to find a way to write a book that just really talks about the evidence for evolution, how much of there is and how much it comes from all different fields, from fossils to genetics to basic systematic biology to biogeography. It comes from every aspect of biology and paleontology and now geology as well. And it's really the story you have to sell, is that we understand evolution to be true because of evidence. And because it's a mountain of evidence, it overwhelmingly points in only one direction. And of course, you can watch it in real time as well. And that was something I did try to bring out in my 2009 book about evolution, what the fossils say. But I thought it'd be better to put a book together which really just outlines the evidence. I was going to go for something really short and punchy with like a 2-paragraph, vignette, and a picture. Never got anybody to take an interest in that. And then, meanwhile, for Columbia University Press, I had found this little gimmick. I was writing books. It started out with the story of life in 25 fossils, then the story of the Earth in 25 rocks, and then the story of dinosaurs in 25 discoveries. And so this is now the 4th in that series, and it sort of makes a nice thread to put together lots of stuff, because it allows me to tell little stories about each piece of the story, about each little piece of evidence. So I often introduce it with a background of how people thought about these ideas and who's been the major people who brought the ideas forward, and a little bit of personal history in some cases of them, and also a little bit about the intellectual framework where these ideas sometimes come from. So it gives me a chance to talk about Darwin and Wallace and von Baer and all these giants of the past who brought evolution to our forefront, but then also talk about people in more recent generations who've come up with the more recent evidence, some of whom I personally know. And so that's turned out to be a very nice little frame. And so I now have 4 books in that series and thinking about a title for a 5th in that series as well.
It's hard because I worry a little bit about covering too much old ground. You and I've talked before, right? Well, what's the difference between a theory and a scientific theory, right? Right. Evolution is just a theory. I mean, I'm trying not to cover too much of that old ground, but real fast, evolution is just a theory. How do you respond to the creationist, etc.?
Yes, the word theory has a totally different meaning in science than it does in the general public. The general public talks about theory. They were talking about something that's wildly speculative, like theories of why JFK was assassinated. Scientists uses the theory for a overarching explanation for a wide variety of evidence. It's the highest level of acceptance in science. So gravity is just a theory. And there's a germ theory of disease, which, of course, right now we're experiencing with a worldwide pandemic. So those are theories, too, but nobody doubts that gravity occurs or that germs are real. Well, there are people who doubt those, but I'm talking about reasonable, educated people. And likewise, evolution is supported by a mountain of evidence just as much as gravity is and just as much as the germ theory of disease is.
Okay, we've done our due diligence then. So I threw out just the most obvious, probably arguably the most common question. One thing about your book I didn't expect is that you sort of jump out into the cosmos. Like I picture you as a guy who's sort of digging in the dirt and the rocks. You're looking for the fossils and you're sort of, under even the microscope, but sort of jumping back to look at life all the way back to the singularity, the Big Bang. You take a larger view in this book.
Well, because the theme is broader than the usual book, which is what I did in 2009, which is, they're talking about evolving systems. And so it involves the planets change as well and the solar system change as well. And so I thought that was appropriate to bring into a book like this. And in addition to that, of course, my teaching responsibility have changed over the years. So when I used to teach a lot of paleontology and sedimentary geology most of my career, now most of the time I teach meteorology and climate science and oceanography. So I find myself thinking about that a lot more and teaching that content a lot more. So I thought that was something that would bring a little bit of a broader frame to this book.
Carl Sagan used to talk a lot about the arrogance of humankind, to think that the whole universe was made just for us. We are the center of all things, right? Arrogance was a word you used in your book.
Right. Well, that's a very popular phrase, cosmic arrogance, or variations on that, cosmic hubris, and so on. But it is something that you learn very quickly as a scientist, both the immense scale of the cosmos, which makes humans look very insignificant and unimportant because we're just a routine little planet on a routine arm of a routine little solar system in a routine galaxy. It's not even one of the biggest galaxies, and it's not even the center of all the galaxies. So we're nowhere near the center of anything in the old theological sense. And likewise, as geologists, we get used to enormous spans of time. So we just think in that frame naturally, which most people have a hard time conceiving of millions or billions of years. But that's normal for us. And yet, of course, it's very humbling when you try to put an analogy together, which I did in the chapter, of how tiny the human slice of time is compared to that. So I use various analogies. I've taught with some of them before, condensing the entire 4.5 billion years of Earth history down to a single calendar year, in which case all of human history is in the last fraction of a second for the midnight on New Year's Eve, which means if you start the countdown early, all of human history is lost.
It's hard for us as human beings to try to process, like processing the universe or processing eternity. Us trying to process what billions and billions of years is.
Sagan claims he never said, of course.
I struggle with it, and I've heard another analogy. I can't remember the specifics, something about if you were to take the span of human existence and you were to analogize it to walking from one coast of the United States to the other, we would have only walked a few dozen feet or something along those lines, right?
Yeah, if you say stretched all of geologic time as a physical distance between, say, San Francisco and the coast of New Jersey, all of human evolution would fit within the last couple of feet of the shoreline. And every time the tide comes or the wave comes in, it would wipe out all of human history.
You're a dinosaur guy. Oh, we've talked about that before, right? You're the little kid who never grew up. I'm not insulting you. These are your words, right?
No, it's not unusual for paleontologists like me to be that way, too.
So I mean, did an asteroid wipe out the dinosaurs? Is that why there are no dinosaurs? Or are there still versions of the dinosaurs? I don't know. It's a broad question. You take that where you want.
There's several answers, but the simple answer is it's complicated. First of all, dinosaurs are still with us because birds are dinosaurs. There's no longer any dissent over that. Hasn't been for a while. And so dinosaurs did survive. So if you want to talk about non-bird dinosaurs at the end of the Cretaceous period, which is the end of the age of dinosaurs, it turns out it's a very complicated story because, yes, a big rock from space arrived, but we also know that the second biggest volcanic eruptions in geologic history were taking place in parts of Western India and Pakistan at the time called the Deccan lavas, which transformed climate right at the end there very dramatically. And we see that a lot of animals actually die out well before the rock from space showed up. So that tells us that it was actually already a bad time on planet Earth when the impact happened. And so there's a lot of people who like the simplistic, the rock from space end of story. And certainly the media like that simple story. But scientists in general don't buy simple stories if the evidence doesn't support them. Yeah, most people in my field, at least, don't agree that the asteroid is the only part of the story.
We also have a lot of misconceptions about the dinosaurs, right? We are the Jurassic Park culture that didn't really see that dinosaurs had feathers and things like. We get a lot wrong, right?
Right. Well, Jurassic Park came at a weird time when we were starting to rethink our ideas about dinosaurs to make them intelligent and fast-moving and with their tails held up and not dragging their reptilian tails on the ground. All that stuff had finally gotten into the consciousness of scientists and, of course, to author Michael Crichton, who wrote the original novel on which everything is based. But by the time the novel was published and then the first movie came out, new stuff was coming even faster. And so we learned between the 1993 movie and its sequel in 96 that dinosaurs all had feathers. And that did not, unfortunately, make it into any of the movies they've made ever since then. Plus, there's the usual round of routine scientific errors all through all the Jurassic Park movies. So I have a sort of a mixed view of those movies. I'm glad that they made dinosaurs even more popular and people are more interested in a modern version of dinosaurs, except that that's no longer a modern version. It's a pre-1996 version. And so we now are sort of cursed by the fact that everyone has just the wrong ideas in their head again, but for the different reasons.
I liken it to like a police officer watching a cop movie and going, oh, God, that's not how that would work. Or a physician watching, doctor dramas on TV going, oh, God, that's not how that works. I'm sure it's a paleontologist, geologist you're looking up going, oh, God, that's not how that works, right?
Yeah, that's a common practice with any one of us who has expertise in the field and then watches us portrayed in Hollywood, is that, of course, Hollywood's about entertainment. It's about storyline. It's about character and narration and so on. And the facts of the case are always secondary to anything like that.
Don't you feel like the facts are more interesting, though? I mean, not to interrupt, but
I think they could do an interesting film without sacrificing accuracy, but who knows? We at Geologists, for example, have a long list of the worst movies ever as far as geologic phenomena go, completely bullshit ideas about volcanoes to the movie The Core, which is voted #1 worst movie ever in terms of earth science because none of it's even been remotely plausible and so on. Those are similar things. We have howlers right and left in those movies. In fact, I teach from them. I usually, if I have a chance, I'll introduce things like the faulty premise of the Poseidon Adventure or one of those movies, and then I'll say, okay, this whole movie is based on a completely false notion, and so everything that follows could never have happened.
I will get to the switchboard in just a second. The Story of Evolution and 25 Discoveries. This is book number what for you? You keeping count?
Let's see. I'm on 47 or 48 now. I have to check my list. I haven't checked in a while.
What makes this one different, though? I mean, if you've done all of these books about evolution, biology, paleontology, geology, I mean, whatever. What sets this one off?
Well, this one's focused strictly on the evidence, which is in a big part of my 2009 book in evolution, but it's focused mostly in just the evidence. I actually don't mention creationists by name anywhere in the book. It's not an attack on creationism like the 2009 book was, because that job was done by that book. I don't have to do it twice. And it also brings in a lot of stuff that was not in any of my books before. So I added, as you mentioned, some stuff about the origin of the universe, the origin of the solar system, and the people who are behind that in the beginning of the book. And then toward the end of the book, there's a lot more about humans and human evolution. And the one chapter I did a lot of research on because I hadn't ever dealt with anywhere in my previous writing or teaching career was where humans are going. A lot of people speculate about what future humans will look like. And I kept getting questions when I did another radio interview from people saying, are humans stopped evolving, or are humans really changing, or what are humans going to do in the future? And so I ended up doing a bunch of research to find out what was really reasonable and what we know. And that's in the last chapter of the book, and it's rather surprising. Turns out, for example, that we are evolving, but not in visible ways that you would never notice. We're not like in the sci-fi movies developing giant bulging crania with bigger brains and wimpy bodies like you see in various dystopian sci-fi future novels, future versions of humans. In most cases, our physical appearance is not changing much at all. It's more of a matter of things that are subtle, like genetic changes. Like, for example, most human populations now retain the ability to digest lactose well into adulthood, which didn't used to be the case because we all weaned from our mothers and then stopped doing that. But in the start of the agricultural revolution, of course, we had farm animals and we began to have milk in our diets through our whole lives. And so the gene for developing lactose is now switched on all the time, and we have the lactase in our system, which means we can drink milk and cheese and all the rest as adults. Likewise, many people know, for example, that we are having trouble, many of us, with wisdom teeth. Our faces have shortened so much since our distant ancestors that the room for all those molars, especially the last set of molars in the back, the third molars, which are nicknamed the wisdom teeth, of course, come in usually late in your teen years. That's why they get their nickname. The wisdom teeth, in many cases, as you know, are crowded. They don't have room to erupt. They often end up, therefore, becoming impacted or otherwise infecting the rest of your jaw. And so a lot of people have to have theirs out. Well, lots of human populations now are no longer develop wisdom teeth. The gene for wisdom teeth is disappearing, and it will probably in the future be completely gone because we'll no longer be able to have room for them. So there's a lot of subtle things. It's tiny things that are in our genome and subtle things in our behavior as well that are evolving. And the physical changes are very subtle. So you can't see them very well because physically our skulls don't look that different from skulls 100,000 years ago, or the rest of the skeleton as well. That part is changing relatively little. It's things like genes for this or that are selected for or selected against that are gradually changing human populations. That's how we're evolving at the moment.
I find this tremendously disappointing. I mean, where are the wings? Like, I want wings. Where's the eye in the back of my head so I can see 360 degrees? I mean, But
That's
I mean, I
sci-fi.
get it. I get it. I get where you're going. Real fast, let me go to the switchboard before I continue my long litany of questions. 314, hi, who's this?
Hi, this is Tia, and I was just calling to ask a question about octopuses, or octopi, however you say it. I heard that they did not fall on the evolutionary chain as of right now. Like, we didn't have any evidence or information about where they fell on it, so they're considered aliens because we can't figure out where they fall in the evolutionary chain. And I just want to know, did he know anything about that, or is that even like his area expertise?
You want to speak to octopi, Dr. Prothero?
Yes, octopi are well understood. There's no question where they belong in evolution. They are cephalopods related to squid and to cuttlefish and to a bunch of extinct animals, and we have a good fossil record of all their relatives. But since they don't have shells themselves, we don't have a good fossil record of them. But there's unless you heard that, it's probably some crank site or some crank program, because nobody has any doubts that octopi are related closely to all the other cephalopods on the planet. Now, there is something interesting I brought in the book on this topic, and that is octopi and some of the relatives have better eyes than we do, or any other vertebrate for that matter. Octopus eye is designed the right way. It actually has the retina, so it has nothing in front of it to obstruct the light coming through, and no blind spot, whereas human eyes and most eyes of our vertebrate relatives have design flaws that make our eyes inferior. For one, we have all these blood vessels and nerves that sit on top of the layer where you have your cones and rods, and so you don't actually see directly at the source of light. Your cones and rods are facing the wrong way, and they actually distort your vision a bit, so you have to compensate for that. And also, because of the way the eye is organized in humans and in almost all vertebrates, our nerve bundle that comes from those cones and rods has to go through the retina, which creates what's called a blind spot. There's a spot in your retina where there's no sight at all. And that, too, is not found. So octopus are actually better designed as visual organisms than we are.
Does that answer your question? Or?
Oh, yes. Yes, it does. Thank you.
You're very kind. Thanks so much for calling the show. Dr. Prothero, would you then see the human eye as a refutation of intelligent design?
Oh, of course. Yeah, that's one of a bunch of things. I have a whole chapter on how poorly designed humans are. And it comes from a lot of different things, just from our poor construction of our eyeball, which is actually inferior to, as I said, to the octopus eye, to a whole bunch of things that come from the fact that we were once quadrupedal, running on four legs, like many monkeys still do, and some apes do much of their life as well. And then we put ourselves up in a vertical position as an upright primate. All sorts of biological and anatomical problems follow from that. They come from a lot of different directions. For example, we all know how your feet and your knees especially, and sometimes your hips as well, are not suited to the kind of pounding that we do when we run all our lives and walk all our lives. And so we have one of the biggest problems we have, of course, is knee problems and foot problems. The humans have all the time. And back problems are similarly related. Likewise, the sinuses in your face, they would normally have no trouble draining out if your head were facing down most of the time, as they do in quadrupedal animals. But because we're upright all the time, some of the sinuses are actually drained in such a way that the holes are up at the top of the chamber, which means they have to fight gravity to go out. And that's one of the reasons we have sinus infections all the time. And likewise, the way our vocal cords and our voice box have shifted the arrangement of the parts of our neck, that has caused a whole bunch of problems, number one of which is, of course, we have this really little tiny flap of skin that shuts off the air valve, the trachea, and opens it so that you can swallow. And then, of course, when you're breathing and not swallowing, it covers up your esophagus. And that's called the epiglottis. And that is very susceptible to problems, because if you, for example, get startled and inhale suddenly, the epiglottis will switch and you'll inhale food or liquid and then you choke, and then you need the Heimlich maneuver. Very badly engineered, and lots of people die every year from choking from that simple engineering flaw. And the list is a whole chapter of examples of how we're badly designed, both in physical characteristics and also in genetic things. We have tons and tons of junk genes that don't do anything anymore. And so I bring that point out. If you think man is created in God's image, that's not very a good reflection on God, actually.
I remember, was it Ken Ham from the Creation Museum? He's arguing about the evolution of the eye, the master design, and he's doing it while he's wearing corrective lenses.
Yes,
right? He's wearing eyeglasses. It was awesome.
Irony is lost in those people. I'm sorry.
Can we talk about the variations of the eye throughout the animal kingdom? Our eyes, the octopus eye, the hawk and eagle eye, the fish eye, are these all shaped environmentally?
They're shaped by a variety of factors. Yes, environment's important, but mostly it's who you're related to. and how complicated the systems are that support the rest of their body. So this is one of the things, for example, I've had this happen all the time, debating creationists. I'll pull out a famous little quote out of context from Darwin's book about the supposed inability to imagine creating an eye, the human eye. And the reality, if you read the entire paragraph in context, of course, he says that there is a solution. Then he spends the rest of the chapter going into it. But they dishonestly take that quote out of context to suggest that Darwin doesn't know how to explain it. And in fact, even in Darwin's time, there was pretty good knowledge of the different kinds of light-sensing organisms across the animal kingdom. And since then, a lot more research has been done. So we have a full spectrum, if you will, of transitional forms of different kinds of eyes, from just little simple spots in a tissue that are light-sensitive to spots in a tissue that are light-sensitive. They're in a little cup, so they help give some directionality to the light source, to the little cup-like eyes that have some kind of a cover on them, like a thin lens on them, which protect the eye and give it a little more focusing ability. And then there are many other versions of these kinds of things which have more than a retina. They actually have a lens. And so you can imagine every step of the way to make an eye is present in the animal kingdom, all the various intermediate steps. And as we just mentioned, in some cases, they've been able to make an eye that's even better designed than ours, as the case of the octopus eye, because it doesn't have the flaws ours does. And the problem with making eyes, of course, is that your eye is basically inherited from what kind of body plan you already had in place. So you can't make it out of nothing. And you can't just suddenly put a very advanced eye on a fairly primitive organism. You usually only develop an eye that's good enough for them and the lifestyle they have. So even in the mollusk, for example, many snails have very similar simple light-sensing spots and maybe cup-shaped eyes because they don't really need to see very well, whereas, of course, their relative, the octopus, has an eye that's better than ours. So it really depends on where in the family tree you are and what kinds of needs are put on it. A snail doesn't have to worry very much, know anything more than shadow is coming, then they can retreat to their shell. But an octopus has to be extremely good at sight, not only to avoid predators because it's defenseless without its shell, but also because it has to be able to spot its prey and quickly stab it and grab it. So those are all things that change with the body plan of a mollusk and then the special adaptations that things like octopi have to do.
One more question about the eye, just because my brain works like this. So if you could choose an eye from the animal kingdom for yourself, like, our eyes are not great. You mentioned the octopus. I mean, if you could design human beings so we had much better eyes, is there a specific animal would you be like, I want that?
Well, in sense of having the fewest engineering flaws, yes, the octopus eye would be the ideal for what we do, right? But many organisms don't need an eye that's very complicated to do what they do, and so they don't develop an eye more complicated than necessary.
Yeah, but I want an eye that will read your book up close, right, but also see a mile down the road at night in heavy traffic. Like, I want that eye, whatever that is.
Yeah, well, nothing in the animal kingdom does that equally well.
Oh, okay. All right. Well, I'm just saying, if I was an intelligent designer, I would just wanted a starting point. In your book, The Story of Evolution in 25 Discoveries, Dr. Donald Prothero, you talk about sort of these early misconceptions about human reproduction. Were most of our attributes in the sperm, or were they mostly in the egg? And when you were talking about this in the book, you used the terms spermism and ovism, which I think sound like adult cable channels, but they are not. You're referring to Darwin's time, right? Before we really understood embryos. Can you sort of put this in civilian language? What's your point?
The point is that embryology, our understanding of how we developed, came through a lot of interesting stages, its own development, if you will. And it started by the fact that there was a lot of speculation about how reproduction occurred and what the parents and the father and mother contributed to making a baby was not well understood until only a couple of centuries ago, primarily because they could not observe phenomena that small until really good microscopes were invented around 1800. And so before that, most of it was highly speculative and sort of guided by what philosophical principle they were doing. So, for example, a lot of people thought almost everything that humans acquired they caught from their father, because the sperm had all the information, the egg was just a receptacle. And there actually were a group of spermists who thought that the entire human body was inside the head of a spermatozoan. And with the poor microscopes they had at the time, they convinced themselves there was a little tiny human being in each head of each sperm. And so they called it homunculus, a little human. And you've ever seen little pictures of a sperm cell with sperm with the tail on it and a little tiny human inside, they actually believe that was true because their microscopes are not good enough to tell that was not true. And likewise, there were schools that thought that all the human information was in the egg, and the sperm was just something that happened to run into it. So there was an ovus school and a spermist school. And of course, by the early 1800s, the debate was finally resolved when they got good enough microscopes to really see what was happening and to watch fertilization take place. And of course, it's hard to do with humans, but things like sea anemones and especially sea urchins have very large eggs which are easy to study under a microscope. They use them in embryology all the time in college now for that reason. And they were first able to watch fertilization take place and realize it had components from both father and the mother, and that's how sexual reproduction worked. And so that's where embryology came from. The context of that, of course, is a framework for where it was by, say, the 1820s. Estonian scientist Karl Ernst von Baer really began modern embryology. And he was the one who launched the idea that if you look at the embryos of a shark and a turtle and a chicken and a human, you'll see that in our earliest embryonic stages, we all look like fish. We had gill slits. We had a long tail. Humans look like this about 5 weeks out of fertilization. We are very fish-like. And then eventually, of course, we all develop in different directions. And so that was information was widely known by Darwin's time when he wrote his book. And of course, he quoted it quite extensively in his book.
I just have this mental image of this notion of the sperm. It's got two little eyes and a smile, and it's just swimming forward.
There's a figure in that chapter that shows a homunculus from the 1500s, with the artist puts a little tiny human in the head of a sperm and believed it was there. And of course, this is before atomic theory, so we knew there was a lower size limit to how big things could get. Because if you believe in a homunculus, then in the testes of the homunculus would be another sperm, which would have another homunculus inside of it. And then its testes would have another sperm, which had another homunculus inside of it. And so you would instantly go into smaller and smaller sizes to infinite regress. You have a position where, of course, it's smaller than anything we can observe. And of course, without a modern atomic theory, nobody knew there was a lower limit to how big a cell could get.
That just sounds like something that would make the universe explode, that infinite regression from the sperm with the eyes and the smile swimming with the full person. That's all right. I'm going to come back to the fish thing in just a second, but I see I do have another caller on the switchboard, 214. Hi, you're on with Dr. Donald Prothero. We're talking evolution. Who's this?
This is Tessa.
Tessa, what's your comment or question for us?
Hi, Tessa. First of all, thank you so much for everything you do. You really inspired me, and I volunteered for recovering from religion, which is the best thing that happened to me ever. And hi, Dr. Prothero. Could you possibly explain how empathy evolved in humans, and how come it evolved in some humans more than others?
There's actually a large scientific debate about that. How empathy works. I mean, to some extent, most organisms that have advanced social organization, from primates to the various things like prides and lions and all the rest, anything that's highly socialized among the animal kingdom, a lot of that will have empathy built in. They will be, of course, very empathetic to members of their own direct family that are genetically closest to them, and often times they will sacrifice their own lives for their own children or whatever. They will sometimes develop empathy for the rest of their troop, or the rest of their pack or their pride or whatever, because there's also often a genetic connection between all those members of that group. So they have a lot genetically to sacrifice for and to sympathize with. And so empathy is thought to be part of that. Certainly we know that chimpanzees and gorillas, when they've done extensive psychological work on them, they can sense other people's emotions and put themselves in other people's shoes and react to it. So we know both Coco the gorilla and Washoe the chimp and some of these other chimps that have been taught American Sign Language can feel for other people that they're close to. There was a famous story how a Washoe, for example, learned that her handler had lost a child to a miscarriage. And the handler communicated this to Washoe, and she was signing back all sorts of signs of respect and sympathy and showing true empathy in the sense that we do. And so empathy is part of being a social organism. Organisms that have highly advanced social groupings, especially in primates, will develop very complicated psychological processes that will be able to understand and feeling of their members of their group as well as humans can.
If I can add a question to her question then, ethical behavior, does that speak to how we were able to be more safe and collect resources? We did better with cooperation and community.
Right.
Does that then lead to a pleasure response, which informs empathetic or altruistic behavior?
Sure. Sure, yeah. Again, something, if you look at Jane Goodall's work with chimpanzees and some of these other jobs that have been done with other large primates especially, their social organization is quite complex. It's very similar in many ways to human society. They understand their obligations to members of their own society, which are usually, of course, their direct relatives in most cases because their groups are small. And then they are, of course, bound by certain conventions. And they don't always articulate them, but they have certain bands of things they won't do and things they condemn other members of their tribe for doing if something happens where that person breaks a rule. Clearly, they don't communicate it by language because they don't have that yet, but they do have unspoken type of ethics, a pack behavior that's all pretty much has to be instinctive and learned as you become a part of a pack. And so certainly some of that was probably conveyed in learned behavior by mothers teaching their children to follow the rules of the pack and to learn their role in that pack, and whether it's in the hierarchy of everything from the top male on down, or whether it's who you can pick on and who you can't pick on and who you can bother and who you can't, to more serious things. And so there's a tremendous amount of research on that now. We have very good understanding of how basically they're simple societies. They don't have many complexities like ours do, but in terms of basic ethics and basic code of conduct, it's fairly well marked out whether they understand it instinctively or whether they learn it from their parents.
Does that answer your question? Do you have something else?
Yes, thank you. It's just the Bible and the Quran are so void of empathy. I always wondered how we got so advanced by now. But thank you so much for your answer. Thank you.
Thanks for calling.
You're welcome.
When my conversation with geologist and paleontologist Dr. Donald Prothero continues, I want to talk more about morality and ethics. We hear this a lot from the apologist. Where do your morals come from if you don't believe in God? Well, let's talk more about science and morality and more about evolution. We'll do it next. My patrons get this show early. They get it totally commercial-free. Thanks for supporting me on Patreon. You are greatly appreciated. Patreon.com/Seth Andrews. Continuing my conversation with paleontologist and geologist Dr. Donald Prothero. He's author of the new book, The Story of Evolution in 25 Discoveries, the Evidence and the People Who Found It. I was doing a conversation on a religious channel the other day, and I got a variation of that. Like, where do your morals come from? How do you know right from wrong? How would you even determine ethical behavior if there's not an objective moral standard? Certainly, you've dealt with the moral argument, right?
Yeah. Oh, it's well established. I mean, that's the irony, is that we know from primate societies that they have a clear-cut morality. They have a clear-cut sense of what is expected and not. In most animal societies, there's an incest taboo. Not all, but there's many of them don't have incest allowed anymore because we now know, of course, incest causes genetic malformations and other problems. And there are other kinds of taboos which are universal to animals, or at least to more developed societal animals. And then, of course, without question, we're part of early human societies long before religions ever came to be. So none of those things are required from religion. Religion has just codified and formalized what was already pretty much understood by every human society that's ever been.
But how much of that is just tribal within species? I mean, you see throughout the animal kingdom, you see one species and they kill and eat the other species. It can be a very violent nature that we live in. How do you approach that in the animal kingdom?
Well, it depends on what you're talking about. I mean, some organisms, of course, have cannibalism as accepted. I mean, very often the case, for example, that a male of a large pack animal like lions will kill and sometimes eat the cubs that were already around because they're from a previous male and they don't want their genes around. Not that they understand any of this, but that's not a taboo in their case. But in most cases, human societies have fairly standard, cannibalism is usually not condoned except in rare cases. The incest taboo is virtually universal among humans and most animals that have it. There's a bunch of things that are well established. And it's just that, as each society changes a bit more, it picks up new types of behavioral norms. And those things then become passed on. And then in most cases, then formalized through a religious taboo. So a religious taboo serves as a way to formally shame restrain people away from doing behaviors they don't accept, but it's only by transferring the authority to a deity rather than by just saying our society doesn't accept this. You say God doesn't accept it, and then you can manipulate people more easily.
Well, that leans into something I think Dr. Andy Thompson, the psychiatrist and skeptic and author, has said, that religions had utility for perhaps creating tribes and tribal bonds among non-kin. Would you agree with that?
Well, to some extent, that's true. We really don't know what kind of religious beliefs any of the more early human groups had, but they always would have had tribal bonds with their immediate family and their immediate relatives, broad family in the broadest sense, because most human cultures were tiny hunter-gatherer bands like they have still today. Many groups in Africa are populations and villages of no more than a few dozen, and everybody's related to everybody else. So they have strong genetic connection between themselves, and they then, of course, have strong system of mores that go with it. And what kind of religion they would have had, in some cases we don't know, but we know that there is a religious component. For example, many of the small hunter-gatherer tribes are still operating that way in Africa. And so religion is just another societal forcing mechanism to formalize what is pretty much already accepted behavior among a particular group.
In your book, The Story of Evolution and 25 Discoveries, you get into sort of the streamlined evolution of the fish. Neil Schumann, he has a book called Your Inner Fish. Of course, he's a famous paleontologist and biologist. I'm fascinated. Wait a minute. We're part fish?
Yeah. Well, you were looked like a fish when you were an embryo only 5 weeks after fertilization, and you still retain lots of fish-like characteristics in your body that you probably aren't aware of, but they all show up if you look at it close enough. Starting with, for example, the development of things like many of the organs in your throat region are derived from the embryonic precursor of the gill apparatus in a fish. So they have the same genetic roots and the same behavior, and that leads to all sorts of weird things in organisms that are not well designed. Like, for example, the one I talk about quite a bit is the left recurrent laryngeal nerve. It's a nerve that loops around from your voice box all the way down to your aorta in your body, and then all the way back up to your spine. So the commands for your voice box that we're using right now as we talk have to go an extra 2 or 3 feet to go all the way down to your chest cavity and then back up again, rather than going the straight route, which is only a couple of inches. And the reason for that is that when you were an embryo, and of course when fishes had embryonic stages, that particular nerve is looped around a gill arch that becomes to the arch just in front of the heart and the circulatory system. And so as that entire system stretched out and migrated backward, it got tied to the artery that coming out of the heart that is part of that, the aorta and some of the others. And so as your neck got longer and as your body stretched out, your gill arch is all stretched out, and that's when the nerve goes all the way back to the aorta and then comes all the way back to almost to where it started. And now that's a big enough problem in a human, although our distance isn't that great and the nerves fire so quickly, it doesn't really make a real difference. But giraffes have the same wiring as like every other vertebrate does, and their recurrent laryngeal nerve goes all the way from their head and their neck, where it's fired from the nerve cord, all the way down 7 feet down their neck, down to their heart, and then all the way back up again 7 feet up their neck in the other direction until it reaches their voice box. And so it's a 15-foot extra extension on their nerve cord for this particular nerve, and it makes no sense in terms of design, because it's the worst possible design. I mean, it's vulnerable to all sorts of things, and of course it's way longer and more complicated than it needs to be, but it makes sense because they had fish-like ancestors like you and I did. And so in terms of evolution, it's something that's not well designed, but it's not a big problem for them because it's more complicated to undo it and rewire it a different way than to leave it as it is, and your nerves fire so fast anyway, it doesn't give them any disadvantage. So that's how we get all these things that don't work very well. That's another theme I hit on the book really hard. That are not well designed. They don't work as well as could have been designed if you picked them up and designed them from scratch. They work only as well as they need to so the organism can survive.
If you look at a creationist and you say you're part fish.
Yep.
Right? I mean, we already in our minds are seeing the expression of disbelief and revulsion.
Yep. Well, but see, that's it. I mean, that's why Schumann picked that particular theme for his book. He teaches medical school anatomy to doctors or to med students, becoming doctors. And one of the things that people who teach human anatomy say is one of the best ways to understand human anatomy is to realize it's not put together in a divine fashion. It's jury-rigged out of the building components of a fish body. And so all sorts of your parts of your body only make sense because you had a fish-like ancestor or a reptilian ancestor or an early primate ancestor. These are the various times in evolutionary history that different parts of your body were wired in. And so they only make sense in context of evolution. And the people I know who teach medical school anatomy, and I've known a lot of them because a lot of paleontologists teach in med schools, they all say that this is something that really helps both them and their students understand why human bodies are the way they are, is to recognize they weren't put together by a divine designer. They're very much jury-rigged and patched together and sort of ad hoc their way through a design that they inherited from ancestors which were nothing like them. And so that's part of the reason we have such a poorly designed eye and all those other things. We don't have a choice. This is the blueprint. This is the body plan we inherited from our distant ancestors. And we can modify it to some degree, but you can't start from scratch. And that's what evolution's about. It takes what's already there, and if it has to make something, it does it the best it can with what's already in the body plan of the organism. It doesn't have a choice to make a brand new organ out of something new.
Now, here's one that really fries the brain of the creationists. I'll let you speak to this. We are the human animal, but we actually have an evolutionary connection to plant life.
Yeah, all cellular animals have a universal common ancestor that goes back probably a billion years ago now, is a rough idea when it occurs, because we have quite a few genes in common with plants, and even more genes actually in common with fungi. So compared to plants, a mushroom is closer related to you than a plant is. And those things are all universal. We have the same basic biological wiring, and even things like the asymmetry in our right or left-handedness of certain amino acids. That's only one way that life does it, even though there's two possible solutions. So all this is, from the genes on upward, tell us how we're related to a common ancestor, and we're all descendants of different branches of the common family tree.
I had a Facebook question from Matthew. He said, do aquatic mammals evolve more rapidly than land mammals, like whale and dolphin evolution? Is there any evidence that aquatic creatures evolve more quickly?
No, I mean, as far as we can tell, I mean, the earliest relatives of whales show up in the Middle Eocene in the early Eocene, if you count the earliest members of the branch, around 55 million years ago, and by 50 million years ago, they're quite whale-like, and by 45 million years ago, we had things like archaeocete whales, which are very modern in many ways, including being up to 50 feet long. So that isn't particularly fast. Many groups of mammals evolve faster, some slower. So they're more or less in the same ballpark. I mean, lots of times organisms evolve fast if there's opportunities. We know this, for example, right after the dinosaurs vanished into the Cretaceous, as we talked about earlier, mammals go from being rat-sized or smaller to within about 15 million years evolving to have whales and bats and all sorts of other adaptations, and including body sizes that are close to as large as an elephant, when they were all tiny 15 million years earlier, because there was nothing to compete with them. They had this wide open planet with no large animals to compete with, and they evolved as quick as they could over 15 million years to diversify and to fill all those niches. So it can go very fast, or most of the time it doesn't go hardly at all. Most of the time organisms, once they find a life form that works pretty well, they stay with that for a long time.
Interesting to hear 15 million years, really the blink of an eye, though, in evolutionary terms. It's like when people talk about the Cambrian explosion, they sort of speak about it like this lightning strike from above.
Right.
Anything else in the book that, we specifically want to dig for? I'm going to put the link in the description box, but I really want to give people, I want to whet their appetite for some of the nuggets that they can use perhaps in their own conversations about evolution. Sure. Anything we haven't talked about yet?
Yeah, I mean, many of the examples in the book are ones I've written about before, but in most cases I've updated them with newer stuff. But much of what's in that book is not from any previous book I've worked on, like all this stuff about humans and where they're going and what humans are engineered like. That stuff I'd never really written at length about in any of my books prior to this one. And what's something else I put a lot of in this book, which I didn't really do in the evolution book in 2009 because it's focused on fossils, I put a lot more about the genetics and how we discovered these things about the gene that tell us a tremendous amount, from the very simple fact, for example, that we're 99% the same as chimpanzee in our genome, which I've mentioned before, to what it means in terms of the 1% that makes us different from chimpanzees. They know exactly what genes those are now and what they affect, and surprise you, it's not all the same ones you'd think. And then other surprises, with the fact that much of our genome is not only junk, but it's all badly wired, and it's all sort of hodgepodge thrown together. The people in genetics compare it to a computer code written by an incompetent that's been modified over and over again. to make it even worse than it was before, because it's not efficiently designed. It comes from a plan that was much more primitive and doesn't get a chance to change. That's how computer codes evolve, and that's how human genes evolve. One of the more surprising things, in addition to all the junk DNA you have, which doesn't do anything and just carried around from generation to generation, one of the genes you never use anymore are called ERVs, or endogenous retroviruses. And what they are is that they're from a retrovirus. Retroviruses are viruses that insert their own DNA into your DNA to make copies of themselves. And so, for example, the gene that causes HIV is a retrovirus, and quite a few others are out there too. When they make that copy of themselves, they insert that DNA into your sequence, so you're able to make copies of themselves while they're active. But then it gets shut off. And so they found, by looking at genomes of humans and apes and many other organisms, that there are ERVs all through them. And that basically what you're carrying around is this unread sequence of how to make a particular now extinct retrovirus. And every human on the planet has carrying these same genes around that have no function anymore from past infections that may have happened millions of years ago. Because they're not only genes that we know came from some human infection, there's some that chimpanzees have that we have, which means they happened for our common ancestor before humans and chimps split. And there's some that are found only in primates, but not in any other group of animals, which means they were infected the ancestor of all primates. So there's some of these retroviral genes are millions and millions of years old. We actually have a sequence of genes inherited, and we carry these now extinct abilities to make this virus in our genome and copy it endlessly and carry it on through generations. And there's nothing to take it out, because evolution doesn't get rid of all those junk genes.
We're dragging a lot of baggage around. Man, that's crazy.
We are indeed. We're the product of a whole bunch of badly informed and poorly designed and jury-rigged solutions to survival is what we are.
But we're in the era of, or approaching the era of, serious gene manipulation, for lack of a better way of saying it. How does that play into evolution?
Well, theoretically, if we can manage to do things like shut on or shut off the genes that create something or infect us in some way, we can do things to manipulate the genome. So, for example, various genetic disorders can be either turned off or otherwise affected, so you don't have the genes that will cause you to have various kinds of problems. And that's at the cutting edge right now. Lots of people are talking about doing that. And there's some cases where they've actually succeeded in doing it to a limited extent. But it'll be becoming more and more the case where we'll be able to manipulate genomes in medical ways so that people don't develop various genetic diseases and are saved from a whole sorts of things that you could be vulnerable to. That's the most direct application to it. Of course, you go on the realm of sci-fi, and then you talk about manipulating humans and make them do things that human can do. That is a little more of an ethical issue, and I don't want to go that direction too far, but it's always possible that we can do some of those things.
It does become a moral, philosophical question. I'm reminded, if I can revert back to Hollywood, there's a film called Gattaca, where they have people who have sort of been genetically improved. They are no longer predisposed to disease. They're more of a master race, for lack of a better way of saying it. And then society sort of classes those people above everybody else, and it becomes this strange moral question, I think one that we're really starting to wrestle with today.
Yeah, well, the sci-fi has taken off on lots of these themes many times, but just like in Jurassic Park, sci-fi only carries it so far, and they often end up carrying it the wrong direction, way ahead of what the science can do or even what the science tells us. So always keep that in mind. It's still fiction. It's still a story, not a piece of science.
You mean I can't stick a needle into a piece of amber and extract DNA from we can't make dinosaur? Like, I want to make a dinosaur. We can't do that? It will never happen?
The chicken, you can make it real easy. And actually, that's something I talk about in the book. Jack Horner's already raised this issue. If you wanted to make a dinosaur, it's not the way you do it in Jurassic Park. What you would do is manipulate the genes of a bird, chicken being the easiest to work with since we have so many of them. And that's already been done. They've manipulated the genes of chickens back in the 80s. We're able to get chickens with dinosaur teeth. Now they have manipulated the genes of chickens in other ways, so they can get chickens which have a long, bony dinosaurian tail. Of course, all modern birds have that tail shrunk down to a little tiny thing they call the Parson's nose, right, which is at the very tip of their hip bone. You can manipulate the genes of chickens so that their feet and their fingers come back, and they have fingers like a dinosaur. And they've done a bunch of other things where they manipulate them and they'll get a dinosaurian snout instead of a beak. So we're already at that point now where we can modify a bird to make it much more dinosaurian. So if Jurassic Park were ever to happen, the only way you would actually have for real is to manipulate enough of the genome of a chicken to make it much more like one of the bird dinosaurs that we have many of fossils now. And you can make that kind of thing. So you can make a velociraptor out of a chicken, but you're not going to make a T-Rex.
A chicken with a tail, fingers, and teeth. I will never sleep again. After visualizing.
Well, that's what Archaeopteryx looks like. It's got a dinosaurian skeleton with feathers. So that's why it's a transitional fossil in the first place.
We've been manipulating genes in different ways, like the banana, right? Everybody looks at the modern day banana and they're like, oh, wow, it's so natural. But the truth is the banana that we see on the store shelves is not. It has been manipulated. It's just been done different. We haven't actually spliced the gene. We've been doing it through crossbreeding, that type of thing.
Breeding, right. With domesticated plants and animals that have been produced over the centuries, right? None of our food crops, none of our animals that we domesticated look anything like their ancestors anymore because we manipulate the genome, but it's all done by selective breeding.
I just picture two bananas. We take two different species of bananas, we put them in a room and say, look, I'll see you in a half hour. I don't know why I just had that.
No, but a banana plant has flowers and pollen, and that's how you manipulate them. That's how horticulturists have manipulated plants for generations. And, of course, bananas the same way. If you ever see a wild banana, it's a stumpy little pulpy fruit, sort of round-shaped, with lots of large seeds in it. And through various types of selective breeding and domestication, they have bred out the seeds, they bred out the shape, and they made it turn into the shape it's now familiar to us. But it does not exist as a wild plant at all. It only consists of plants that we've cultivated, which is ironic, as some of you in the audience probably know. Ray Comfort, the famous creationist, keeps making statements about how the banana is so perfectly designed to be fit inside a human hand. And, of course, the banana is that way because we bred it to be something we can manipulate.
What a weird and fascinating, strange, amazing world you live in, Dr. Prothero. Yep. The stuff that you navigate on an hour-by-hour basis. All right, to cap off our conversation, just kind of give me the brochure. Like if you could summarize why people should dig into the book in, 60 seconds, what would you say?
Well, the book is about all the evidence for evolution that I could squeeze into 2 covers that tells you all the amazing things we've found about life and about the universe that only make sense in the context of evolution. And that encompasses everything from the understanding of how the solar system formed to the various lines of evidence that evolution that Darwin realized in 1859 to all the newest stuff that's come from paleontology and genetics and to where humans are going. That's the book in a nutshell.
I will include the link to that in the description box of this broadcast. It's called The Story of Evolution in 25 Discoveries. Dr. Donald Prothero, it is always a joy and a real education to speak with you, and thank you again.
Thanks for inviting me.
Follow The Thinking Atheist on Facebook and Twitter for a complete archive of podcasts and videos, products like mugs and t-shirts featuring the Thinking Atheist logo, links to atheist pages and resources, and details on upcoming free thought events and conventions. Log on to our website, thethinkingatheist.com.